Welcome all. Hello everyone. Welcome to part 2 class 4 of CM1. This is going to be a very important class for you because you will develop the basics and you will be able to know how to make use of a random variable. By the end of this class, you will have a basic idea of how the insurance policies work at a basic level, I'm saying. So here if you see, we'll start with this one, the basic types of policies. We have four kind of policies here. The first one is whole life assurance policy, and the second one is term assurance policy. In term assurance policy, the validity is only for a term, and the third one is pure endowment assurance policy. Here benefit will be given only on survival, there is no death benefit. And the fourth one is endowment assurance policy. When I say endowment assurance policy, both the benefits are available here, 2 and 3. 4 is a combination of 2 and 3. And for all the kind of policies, we have two types here. Benefit is payable at the end of year of death. This is the first one. And in the second one, benefit is payable immediately on death. These are the two types. Here we will make use of a random variable. In today's class, we'll discuss how to use kx, and in the next class we'll discuss how to use tx, the continuous random variable. Kx is called cut lifetime random variable. We'll see how we can use kx in today's class. Let's proceed further. When I say whole life assurance policy and this guy will buy policy from the company, then what will happen? Now he is fit, this guy is fit and fine, so there is absolutely no problem. This guy will purchase a policy from this company. So if this guy has the policy, when the benefit is payable, he has a policy. Okay, now because he purchased a policy now from the company, the age is important. Let me write the age here. Age is suppose 30. Whenever this person dies, he has to specify in the policy someone's name, and if this guy will die, here benefit will be, there is a benefit. This means benefit. Okay, if the person dies, there is a benefit. If the person dies here, there is a benefit. Maybe this is 40 years, 55 years, doesn't matter, 78, 82, whenever the person dies, there is a benefit. Will not worry about the timing of the benefit. Remember, when I show you this one, money, benefit, okay, there is a benefit and the term is whole life, the validity is whole life. So we'll write mathematically up to infinity. However, we'll restrict it up to 120 only. That's a separate thing. Remember, when we say whole life policy, benefit is payable whenever the person dies. Okay, so the benefit is payable whenever the person dies. Remember, suppose this guy is fit and fine now and purchase a policy. If the person dies here, anytime, this is the number line, the benefit will be payable. When the benefit is payable, it will be payable here or here. There are two types. Okay, if the benefit is payable here, then you can say the benefit is payable immediately. Okay, suppose this is 3047 48. If the person dies here, 7 divided by 12 here, benefit will be payable immediately here or here. Okay, there are two ways. Okay, these are the two ways. We'll not worry about this now. In the A part, we'll consider only about this. In the A part, we'll not worry about this one. We'll consider only this one now. Okay, we are not interested in this one now. At least for the next 2 to 3 classes, we'll concentrate on this one, benefit that is payable at the end of year of death. Okay, now let's go to the second one, term assurance policy. When we say term assurance policy, there is a term. Suppose this guy is 30 now and he would like to purchase a policy. This is a legal document. Whenever this guy dies before 50, remember, then only there will be some benefit. So let me write the term also. Term is 20 here. These are important. Present age is 30. Term is 20 here. Whenever the person dies, he or she will get benefit. When I say he or she will get benefit, the benefit will go to the dependents. Okay, the nominee, you can say. But where is the benefit payable? Within 20 years. That's important. If the person dies after 20 years, there will be no benefit here. If you check here, there is no benefit. Maybe this is 26th year. No benefit will be payable here. This is term assurance policy. Term assurance policy are valid only within the term. The term could be 20 years, 30 years, 40 years, 10 years, 5 years. Any term if you want, you can write here. It's not that the term is fixed here. I can write 35-year term. And then in that case, the validity will change. Okay. So I can write 35 timeline. This is my timeline and this is my age line. Okay. So here 0 to 35 and 30 to 65. 65. Okay. Now this is term assurance policy. And in term assurance policy, this is valid only within a term. But now, as I already said you, will only think about a type of policies. The policies where the benefit will be payable at the end of year of death. Fit and fine here. Person dies here. Benefit will be payable here. But if the person will die here, there is no benefit. Okay. The term you can mention. So there is a starting time that is 0 and there is a term, suppose 40 year. Someone takes at 20. It will be valid only up to 60. If the person dies after 60, there is no benefit payable. Okay. However, when we say the timing of the payment, we have divided into two parts. One is payable immediately. The other one is payable at the end of year of death. We are talking about this one now. The first case is when the benefit is payable at the end of year of death. Suppose this is 25. Okay. 20 plus 25, that is 45. We can write here 26, 46. So the benefit will be payable here. Suppose the benefit is 10,000. This amount is payable at the end of year of death. So what will be the cost for the company to pay this amount? The cost will be the present value of 10,000. That is 10,000 V. So when you write 26 will come here, not 25. Because this guy dies between 25 to 26. And the benefit will be at the end of the year of death. So the present value here will be 10,000 V power 26. Remember this amount. This is the amount, whatever. Let's proceed further. The third type of policy, that is pure endowment policy. You should know what is endowment. Endowment means something in a positive sense. This is a benefit. Okay. The benefit will be payable only when the person survives. Suppose this guy is 30 now and there is a 20-year, all are term actually. This is also term. Suppose the term is 20 years. So within 20 years, if the person will die, then there is no benefit here. This is survival benefit. Let me write. This is survival benefit. Okay. This is death benefit. Let me write here. This is a death benefit. Okay. The person has to die. This is term. First one is whole life. Will not worry about what kind of benefit. That will be death benefit only, because that is whole life. Anyway, there is a benefit. But here, benefit is not guaranteed. Only if the person dies within a term, then only benefit is guaranteed. Term, when I say only death benefit, remember. But term is used for death benefit here in life insurance policies in this context. But here, this is finite. This is a term. Here also, this is a term. But this is called pure endowment. Pure endowment means benefit will be payable on survival to the end of the term. Okay. Now, this is the benefit. The benefit, they might be same, they might be different also. We'll discuss later. Here, suppose the person survives. Now, this guy is presently 30 and the term is suppose 20. And the person survives, then benefit will be there. Okay, here benefit will be payable. So you need not worry about the time of the payment here. The time is fixed. Okay, they will see whether the person is fit and fine or not, whether he can come to the company to take the benefit or not. They will watch whether the person is dying or not. If the person will die, then there is no benefit at all. However, if the person survives to the end, then there will be benefit. We'll discuss more about these kind of policies later, but remember, particularly for Indians, these kind of policies, Indians feel these kind of policies are not beneficial because only when the benefit will come, only when a person will die. That is the reason. Okay. But in UK, most of the people, they purchase term insurance policies. We'll see mathematically why this is beneficial, why not the other one is not beneficial. Okay. Let's not worry about that. But here we have another one, endowment policy, that is pure. When I say pure endowment, that is pure survival. Okay. That's why the word pure here. Pure means what? Only survival benefit. Now, when I say endowment policy, both are there. When we say endowment assurance policy, both are there. If the person dies, there is a benefit. If the person survives, then also there is a benefit. So here 0 to 40, okay, 40 years. Then what will happen? Whenever the person dies, there is a benefit. Again, when you talk about the timing of the benefit, it could be immediately here or end of year of death. But we are considering this now, the A part. So the benefit will be payable here. Not only that, if the person survives to the end, then also there is a benefit. Now, initially you see the amount of the benefits will be equal. The survival benefit and the death benefit, they will be equal, but they might be different also. So you have a bigger benefit if you survive. This is also possible, but you have benefits here, here and here, or maybe sometimes here and here. This is endowment policy. I hope you know about random variables by now. If you don't know, you can go and revise. Random variable, okay? Let me say something about random variable. Why the concept of random variable? Remember, this is very, very important in CS1 and in actuarial science, okay? The concept of random variable. It's very simple. Remember, when I say something which is not known, then concept of random variable comes. If you think of a number, I don't know, then that's a random variable, okay? So if someone calls me and says, I need some amount from you, if I answer, see Mr. X, you are a good friend of mine, but the problem is I am giving a class and I'm not sure how much cash I have now. So you come, I will check whatever I have, I will definitely contribute to you. Then it's completely random. For him, for this guy, there is absolutely no idea how much amount he will get from me. It's a random variable. Random means no idea. Then he can further ask another question like, it's okay, you are giving a class, I can understand, but if he could say some possibilities, I can plan ahead. Okay, this guy says, listen, you can say how much you will be able to afford, but if you can say the amounts, I mean the possible amounts you can contribute, that would be great because I can plan ahead. Then I can give him some information, like it could be 10,000. Okay, then we'll write this way. This is the notation. X is equal to 10 means the value of X is not 10. This is the notation you need to remember. X is 20 or maybe 25, 30, whatever. Suppose I say 3 options. So X is my random variable and my options are 10, 20, 30. These are called events. The event that I will be able to contribute 10,000, there is a chance because I have not checked how much cash I have now presently. So these are the events. Then we find probabilities, probability of these events. Total probability will be equal to 1. Okay. So if I specify, I can contribute either 10 or 20, 30. He can ask another question. The first question was whether you will be able to afford some amount or not. I said yes, but I can't say now. That's a random variable, completely random, no idea, absolutely. The second question, how much you will be able to afford? You specify. Like if you ask me when you will take our next class, if it's random, I have to say something. It will be either on Thursday or Saturday or Sunday, whatever I have to say. I have to specify something, right? So now I am specifying 3 options. So then there is some information. It's completely random. Now some information. What are the chances? We write this way. These are the notations. And what are the chances? We'll write here. These are called events. These are called events. These are called probabilities. And this is called random variable. Okay. And the probabilities, again, he has to ask me third question. Possibilities Then chances, you can say probabilities. 3 questions if he will ask me, he will be able to know something. Okay. If I say no, there is a 50% probability. If I answer this way, I have a 50% probability that I will be able to contribute 10,000. I have a 30% probability that I will be able to contribute 20,000. I have a 20% probability that I will be able to contribute only 20,000. There is only 20% chance that I will be able to contribute 30,000. Okay. So here's some information now. From no information, here's some information. These are the notations. Now, in the context of life insurance, remember, age is very important. This will be our first random variable, kx. Not only k, we have another subscript here because age is very, very important in life insurance. Okay. So, not only the random variable, but also extra level of complexity. So, initially, you might feel it a bit hard to accept, but yeah, it will be very easy. See, the notation was only x. I must have sent you some videos, okay, to know about the random variable concept. Now, in addition to x, we'll write a subscript also. And the subscript will not be important, but that is required because we have a random variable for every age. Suppose I write k30, it has a meaning. We'll go to that. K30 is a random variable. K40 is a random variable. K41 is a random variable. K42 is a random variable. All are random variables. We are not talking about one random variable in CM1 part 2. We are talking about so many random variables. You can start from 20 or 15 or 25, K25, K26, K27, K110, K119, K120. What is K30? Why there is a concept of K30? It's like this. Suppose the person is 30 now, okay? What will happen is, if the person is 30 now, fit and fine, when the person will die, if the person is 30 now, when the person will die, that is important. What are the possibilities? This guy might die here, fit and fine, might die here, or in the second year, or in the third year, or in the fourth year. So you need to count, okay? Suppose this guy dies here, you count this way, 1, 2, 3, 4, 31, 32, 33, 34. This is like a counter. Kx is like a counter. So I am talking about K30 here. So I've taken X30. So K30 is a random variable. Forget about 30 now. K is a random variable. You compare the random variable X with K. K is the random variable, but we are considering the people who are aged 30 now. We are considering only the people who are aged 30 now. Okay. So the present age is 30. If the person dies here, then what will be the value of kx? In this case, the value of K30 will be equal to, you count this way, 1 year, 2 year, 3 year, complete. This is called cut-at lifetime. Cut-at lifetime means you will not consider the fractions, okay? Like whatever 2 month or 3 month is here, or maybe number of days, will not count those. Suppose the time is actually 3 year and 7 months, okay? This 7 month will not count, or whatever time, this time will not count. Will count only the whole years. How many years the person survived before death? Here you see the definition. The number of integer years a person will survive whose present age is x. Okay, whose present age is x. So when I ask you what is the value of K30, here in this diagram it's 3. It's not always 3. If the person will die here, then it will be 1. If the person dies here, then K30 will be 1. This is the random variable. In this case, K30 will be 1. Means 1 year survival before dying. The complete year you have to count. Okay. Suppose I will give you 2.5 hour class today. Then the curted one will be 2. You just count 2 hours. This you need not count. Suppose I will continue to give you more time, 3 hours 15 minutes. Then you leave this one. You say it's 3. So you have to use positive integers. Okay. That's why I have written integer here. The number of integer years a person will survive whose present age is x. Okay. So what are the possible values of K30? It could be 0 if the person dies here. It's like me giving you a 45 minutes class. Me giving you a 45 minutes class, 45 by 60. Here I started. Here I ended. Okay. 45, I mean, if I end up with a 45 minutes class, then you have to count 0, not 1 even. I have to cross 1 hour. So here, if the person crosses 1 year, then only we'll consider 1. So what are the possible values of K30? 0. If for the time being you forget about 30, because that X brings another level of complexity, as I already said you. K could be 1, then K is 2. In this hypothetical world, all the persons, they are 30, age 30, okay, will not write 30. So the values of K are 0, 1, 2, that way. K0 means what? The person died within the first year only. He was unable to cross 1 year. 1 means what? He survived 1 year, he died in the second year. That way it will continue. So let me write 30 as well. This way it will go. It could be 3, then K30, 100, no, it will not go to 100. So I can write 80, that means 110. So he can survive up to 110. What is the meaning of this? 89, 30 to 89, okay. That is 119. Up to 120 we can do it, okay, because in the actual table we have up to 120. So the maximum value of K30 will be 90, okay. That means the person will die between 120 to 121 here. Here there is a 100% probability that this guy will die here. There is no way he can survive, okay. All possibilities, these are the events. These are the events. If you write a P, then you will get a probability. So what is K30 here? K30 here is the number of integer years. The number of integer years a person will survive whose present age is 30, okay. The number of integer years a person will survive whose present age is 30. Try to commit to memory now, not later. If you want to continue with the class, remember now. I'm giving you time. The number of years, the number of integer years, we are not worried about the fraction here. A person will survive whose present age is X. So the values I've already written here. K30 is a discrete random variable, okay. Discrete random variable, remember, discrete random variable. And what are the values of K30?
0 to 90.
Yes, I've written all this. This is one event. This is the first event. Second event. Event that this will happen. Event that the person who is aged exactly 30 now will die within 1 year. The event that the person will die within 1 year. The event that there will be a class for you tomorrow. The event that it will rain tomorrow. Event is different from probability. Event is an event only. When I write P, it gives a number. This is the event that the person who is aged 30 now will survive for 2 years and will die during the third year. Then only K30 will be 2. It's not only survival. See, if I draw a line here and I write this person will survive for 2 years, that's fine. But that's not all. Because it could be 3, right? If the person dies here, then only it will be 2. So this says two things. This says two things. The person will survive for 2 years. Along with that, he has to die during the third year between 32 to 33. So if I write a P here, then what will happen? Because this is the event. If you write a P here, then you will get an answer, okay? You'll get one answer that could be 1 by 2, 1 by 3, 1 by 10, 1 by 100. This will be a number. Probability is a number. But here we'll use the notation. Remember the notation for this? That was P32, okay? Probability that a person who is presently 30 will survive for 2 years. Not only that, he has to die here. So we'll write this one, Q31. So remember, if you want to write this one, you will get this one, P32, Q30, okay? Let me write P32, Q32. Sorry, this is 32 to 33, okay? Now, if you like to write this one, okay, then you will get a number, okay? But now we have to know, we'll see the table and we'll write all this, but that will come later. So these are the events. If you write P, these will be probabilities, okay? We'll write all the symbols using P and Q. Then we'll write in the form of a table. These are all possibilities, okay? Now let me write the probabilities. using P and Q. This will be QX directly because the person is fit and fine at 30. However, unfortunately, this guy will die within 1 year. So that is Q30, Q30, dying within 1 year. That's how you didn't get even 1 year score. Okay, so Q30. Even if you want to write in the form of a formula, you can write P30, that is 1. Surviving from 30 to 30 plus 0, that is 30, that is always 1. You can write Q30. And the second one will be surviving for 1 year, this way, then dying during the next year. This should happen. Using PQ symbol, we can write this way, P31, Q31. This will be P32, Q32. These are the symbols. These are the actuarial symbols. You need to remember. P33, Q33. Okay. This will be P34, Q34. These are the symbols we are developing now. Not only that, we have two types of symbols. Okay. This is one type, and the other type also you need to remember now. This is Q30. Okay. And this one is P30, Q31. This one is P32, Q32. These are the symbols. Okay. Actuarial symbols. These are the probabilities. Total probability will be 1. Will not be worried about those now. So the other kind of symbol is, remember, P31. If you want, you can write 1 deferred Q31. This also you can write. Okay. 1 deferred Q30. Sorry. 1 deferred Q30. For this one, you can write 2 deferred Q30. This means 3 deferred Q30. In part 2, we have a lot of symbols. You need not worry. You need to remember, that's all. 4 deferred Q30. These symbols you need to remember. So what is the meaning of this actually? We say the person will die ultimately, but before dying, he or she will survive for 1 year, complete 1 year. Okay, he or she will survive complete 1 year. Here, complete 2 years. Here, this one, P32. This complete 2 years we write here. And we write the present age. This means it will be this way. You can interpret seeing this symbol. You write 30 here, 32. This is the complete survival. And then this guy is to die here. Q30. Q30 means it's not dying between 30 to 31. This 2 year deferred. The death will be deferred by 2 years. That means you will survive for 2 years. Then will die within the next year, during the next year. And the present age is 30. And this way, everything is here. Present age is 30, survival for 2 years, dying within the next 1 year. And the one we don't write. Okay, that's all. Now, you have to remember both the ways, because sometimes you have to write this way, sometimes you have to write this way. So let me write here small k for this one. Okay, this is small k. It could be 0, 1, 2, 3. It will continue. And what is probability that kx is equal to k? Okay, let me write this way. What is the probability that k30 here, k30 is equal to 4? Okay, we've written this one. I have to copy. What is the probability that this is 3? I have to copy this one. Let me write it here. P33, Q33. How about this? P32, Q32. How about this? P31, Q31. How about this? Q30. Okay, dying within the first year. This is the table. If you add all the probabilities, that will be 1. Sum up all probabilities will be 1. This is something you have to know. That's all. This is something you have to know from CS1, or if you are not from CS1, even if you know a little bit of statistics, even if you don't know statistics, you studied probability in 12th class. That's all. This is what we require, and the expectation variance. Okay. If you have some problem understanding whatever videos I refer you to watch, you go and watch once again. Still, if you are not able to understand, I have, very simple videos. Okay, you can go through them. There are 7-8 videos you can watch if you want to develop more ideas. Okay, if you say me, I will forward those to you. Now, suppose this guy is 45. Suppose this guy is 45, okay? 46, 47, 48. Time starts now. Time starts now means this guy is 45 and he wants to purchase a policy, okay? I'm not saying what kind of policy, term policy or whole life policy. You can make it a whole life policy. Then we don't know when this person will die. This is an assumption. If the person dies here, then the company will pay here. So remember, the benefit will go here. If the sum assured is S, the discounted value will be SV power, you count here, 1, 2, 3, V power 3. Okay, the present value or the discounted value will be SV power 3. We talk about present value in CT1, which is part 1 of CM1. However, in part 2, we talk about expected present value. When we say expected present value, we'll consider all options, not only one option. If you consider one option, it's only taking the present value. Because we don't know about the mortality of this guy, we don't know about the lifetime of this guy, okay? It's a random variable, but we have options, okay? He might die here or here or here or here. These are the options we have. We'll consider all the options. There is a derivation here, okay? So what will happen if you write x here instead of 0? Sorry, if you write x here instead of 45, this will be x plus 1, this will be x plus 2, this will be x plus 3. That way. You can continue this way, okay? But we'll consider all the possibilities. Let's proceed further. Now, let's come here. The age is 40. So, if the age is 40, what is the probability that K40 will be 0? These are all the possibilities. I have not written all the possibilities here. I have written only few possibilities here, okay? These are the events. Possibilities, I say, okay? Not the probabilities. These are the possibilities of K40. What is the random variable K40? What are the events or possibilities? These are the possibilities 0, 1, 2, 3, 4. And these are the events. The events means we can't write an equality sign here. These are the events. If you want to write something, you can write this way. This is the event. Event. You can write event, okay? Even that K40 will take 0. Even that the person who is presently 40 will die within the next year. Even that the person will die between 40 to 41, whose present age is 40. So what is K41? This is an event. Event that the person will die within 40 to 41, whose present age is 40. He was unable to make at least 1 year. He died before 1 year, within 1 year. So K40 will be 0. How about this event that the person will survive for 1 year? Okay, the person will survive for 1 year. And die within the next year. That way you can write for this one, you can write for this one, you can write for this one. This one will be fixed, okay? The person will survive for 2 years, 3 years, 4 years. That way you can continue. And then he has to die. The first one, only death, no survival. Okay, here 1 year survival, 2 year survival, 3 year, 4 year. Whose present age is 40. We have to write that one as well. See, lot of repetitions for you. Okay, so that you will not forget. I want you to remember now. 40, 0, Q40. This is P41, Q41, P42, Q42, P43, Q43. Okay, 100 times you will write these things later. P44, Q44. That's all. and I can write here K, probability K40 is equal to K. See, this K is small k, this K is big K. 40 we write because the policies, whenever we talk about life insurance policies, they're age dependent. 40 has nothing to do with this, okay? Yeah, I mean, from 40, the mortality will come. That's a separate thing. So you write 0 here, 1 here, 2 here, 3 here, 4 here, that way. You write Q40, P41, Q41. For this one, if you want, you can write 1 deferred Q40. This one will be 1 deferred Q, 0 deferred Q40. This will be 2 deferred Q40, 3 deferred Q40, 4 deferred Q40. That way it will continue, okay? P42, Q42, P43, Q43. That way it will continue, okay? So these tables are very, very important. Now the general number X, okay? Now X is the unknown. Kx is equal to 0. This is the event that the person is presently X and will die within the next year. So this is the event, dying between X to X plus 1 here. Similarly, X1, X2, that way. And you write this table. You have to remember this table. Probability K will be equal to K, small x. Sorry, this is not important. Here, small k. You can write any other number as well here. You can write T also. It doesn't matter. This is a dummy one. I can write 0, 1, 2, 3, all. And this is very important. Qx, Px1, Qx plus 1, Px2, Qx plus 2, Px3, Qx plus 3. That way it will continue. And if you want, you can remember this way as well. There are two ways, okay? Because this is important, I've written this one within the box. If you want, you can erase these and you can replace by these numbers as well. I'm writing here, it doesn't mean that you have to write 2, 2. One is sufficient, okay? Either you write this line or this line. Even you don't need to, we're developing now. See the possibilities I've written, all the possibilities, okay? Suppose one will take a, how many year? Count here, 1, 2, 3, 4, 5, 6 year term insurance policy. If this guy has taken a 6-year term insurance policy, then what will happen? If he dies here, benefit will be payable here. If he dies during this year, benefit will be payable here. V square, SV square, SV. If the person dies here, benefit will be payable here. If the person dies here, benefit will be payable here. If the person dies here, benefit will be payable here. If the person dies here, benefit will be payable here. That's all. This is not whole life. This is term. 6-year term insurance policy. These are all possibilities. So if you don't want to use random variable, you need to do a lot. See how I can derive. This one I will write this term. What is the probability that the person will die between 30 to 31? Or if I start with X, let me start with X. What is the probability that this guy will die between X to X plus 1? Qx, right? With this probability, if the benefit is 1 now, let's start with 1 benefit. The benefit will write here. Then you have to discount it because we are finding the cost now. We are finding the present value of the cost. The cost will not be 1 for 100% because there is only some probability that the person will die. So I'm multiplying with the probability. What I'm finding is I will find the expected present value. Expected when I say average present value. Okay. So this term will give you the amount company has to pay in respect of those people who will die within the first year. Suppose I will sell 10,000 policies. I'm interested in those people who will die within the first year. I will pay them only. If you start with 1, in probability we start with 1. If you start with 1, there is a probability that this guy will die. Okay. So I'll multiply with B. How about this? 1 year survival, 1 year death. So in this case, it will be Px1 1 V square. Okay. Sorry, Q also I have to write. And this one will be surviving for 2 years, Px2. Then Qx plus 2, V power 3. Not only I'll find here the benefit 1, that benefit discounted value I have to find here. These are OR cases, remember. These are OR cases, not AND cases. this will happen, or this will happen, or this will happen. So we have to add everything. Okay, it's like this. There is a 10% probability that something will happen. There is a 20% probability that something else will happen. What is the probability that something will happen? So we have to add probabilities, right? That way we have to add all these probabilities. These are OR cases, okay, but these are AND cases. This and this should happen. Okay, see, I'm multiplying here, but these cases I will add. So what will happen ultimately? If this is a whole life policy, then it will continue. Okay, it will not end. So you have to add all possibilities. Let me write all the terms. First term QX, second term, sorry, present value also I have to find. So let me write expected present value of benefit. Okay, in case of whole life, not only that, present age is X. Then what is the expected present value of the benefit company will pay? QXV, PX1, QX plus 1, V square, then Px2, Qx plus 2, V power 3. It will continue. And remember, if you add all the terms, that will be your Ax. This one will derive now. Using random variable. This is by general reasoning. Remember, this one by general reasoning, and we'll derive this one using random variable. Okay, we'll get the same expression. Using summation, I can write Pxk, Qx plus k, V power k plus 1, k0 up to infinity. Mathematically, this should be Ax. Now put k0, you will get the first term. Put k1, you will get the second term. Put k2, you will get the third term. Put k3, you will get the fourth term. That way it will continue. Okay, one time you need to develop, that's all. We'll derive this one. This is by general reasoning, but we'll derive this one. Okay, yeah. Now suppose this is 0, this is 1, this is 2. I'll not write it 3. Okay, it could be any number, maybe 30. Now this guy is 30, and suppose this guy will die between 60 to 61, that way. Okay, dot dot I've written. If this guy will die here, benefit will be payable here. We'll not do one by one. See, there are 6, so I've done one by one and I wrote everything, but we'll not do this way. Okay, this way also you will get it, not a problem. But this is also important. You need to know this derivation also. It will not come in the exam, and after 1 or 2 classes you will be solving all problems. But if you know this, clarity will be more. How? Listen. If the present age is X, I'm writing this way. So one thing if you need to know in this chapter, remember this one. Okay, initially for the first time you see, you might feel it a bit awkward. Okay, but you need to learn. It's learning time for you. This will be kx plus 1. Okay, this is the notation. Now we remember kx. What is kx? I can give you one example. Suppose one guy is presently 30. Okay, he survives for 3 years and dies here. Then we write k30 is equal to 3. Okay, 1 complete year, 2 complete year, 3 complete year. We don't count this. We don't count this one. Okay, so we say k30 is equal to 3. So this notation, k30 is equal to 3. So if I count this way, this will also be 3. You see, 3, the match. Because we count from here. If you count from here, this is 1 year, this is 2 year. This one is like, if you count that way, up to kx you will go. Because we are not taking this into consideration. We'll leave this fraction part. So you will end at kx. Okay. Instead, if you want to use this way, I will write, instead of 3, I can write here this 3, because k30 is equal to 3. I can replace 3 by k30. I can replace 3 by k30. Okay. because the age is 30. Because K30 is 3, I can replace this one. Otherwise, if you want to remember, just count, okay? Count this way. 1, that means 1 year over. 2, 2 years over. Like that, kx years over, okay? And the fraction we don't take. So this will be kx, that's all. Because kx is the current lifetime. Kx will always be an integer. Kx will be either 1 or 2 or 3. Obviously, I've written up to 2 years. Suppose this is 30, okay? Kx is 30. And the present age is 30. Then this comes here in the first line, remember. This is 30. So here it will be 60 and this will be 61, that way. You will not get anywhere this number line. It makes life easier. So remember this way. However, the benefit will be payable here. We're talking about benefit of 1 unit of money. If that is payable here, you have to find the discounted value. And if you count 1, 2, 3 this way, though current lifetime is kx, but money will be payable at the end of year of death. And the discounted value of that money, that amount, will be v power kx plus 1. See, this kx plus 1 is like 61 or 50, whatever. This is a number. Okay, this is my present value. Then I have to find expected present value. Okay, let me write PV. That is v power kx plus 1. Then I need to find expected present value. That will be expectation of v power kx plus 1. And the notation for this one is x. When you find expected value of something, suppose ex you find. Let me write a simple example. There are only two options for x. They are 1 and 2. And the probabilities are, suppose 70%, 30%. When you find ex, you write this way. This is the expected value of x. When you find ex square, what we do is, wherever x is there, you replace it by 1. That's all. If I write ex power 3, you write 1 power 3, 2 power 3. Probabilities will not change. If I write e2 power x, it will be 2 power 1. Wherever capital X is there, replace it by the value. Okay. So 2 power 1 probability, that is 0.7, 2 power 2, 0.3. This way you will get. Okay. If you get 2 power random, this is the primary random variable whose distribution is given. Okay. Instead of that, if you have x plus 3, then also you just replace x by 1, then replace x by 2. If you want to use summation sign for this one, for 2 power x, you have to use this way. Summation 2 power x, probability, capital X is small x. These are probabilities. Okay. Probability that x is 1, that is equal to 0.7. Okay. So this way you have to write. Wherever big X is there, you have to write small x. See, I will write x1 to 2. If you open this bracket, you will get 2 power 1, probability x is 1, that is 0.7. 2 power 2, here I have written probability x is 2, that is 0.3, that way. Here we will write, you have to know what is the random variable here. V is not random because interest rate will be given. V is 1 upon 1 plus I. V is not random. So this type of thing, okay, 2 power, like V power, okay. So we have to write summation V power small k plus 1, probability capital K is equal to small k. You practice it and you remember it, that's all. K x we write because we are interested in the age, but it's exactly like this, okay. And K will be 0 to infinity. Now, this is expectation formula. If you don't know, go through more videos of CS1 or maybe statistics. I will not say you need to study CS1 for this because CS1 is a whole lot. Maybe you need 70 videos. But for that, we need only 4 videos of CS1. Or maybe if you are from statistics background or if you know a little bit of statistics, go through those 2 to 3 videos once again. Now, this is the derivation. Okay. We'll expand. We'll see term by term. I've written in 2 ways. The first one by general reasoning, and the second one taking random variable into consideration. Okay, let me write the formula. Whatever you write, suppose I write summation k0 infinity, then p xk q x plus k v power k plus 1. Why k plus 1? Because plus 1 is there. If I replace it by, suppose you need to find e 2 power x plus 1, you have to write this way. Summation 2 power x plus 1, probability x is equal to x. Okay, so wherever capital is there, replace it by small x, then write probability this is equal to this. Okay, so this is the random variable here, whose distribution we have written in a tabular form I showed you before. That random variable is this, okay, is small k here, and you replace capital X by small x. You replace capital K by small k. That's all. K plus 1. X we write for age. So we'll expand this now. We'll see term by term how it looks like. Just put k0. Okay. If you put k0, px0, that is 1, qx plus 0, that is qx v power k plus 1. This is the first term. Remember, we derived using general reasoning. Then the second term, px1 qx plus 1 v square. Then px2 qx2 v power 3, px3 qx plus 3 v power 4. We'll not find all this. Everything is already calculated and given in the actuarial table. The total will be ax. Okay, this is the derivation. You can see a30 from the table. We have already used a30 from the table. Suppose a30 is given 0.16 at 4% interest. That means if you have no work, you can calculate this one, a30. Okay, how will calculate a30? You put x30, q30. You need q30 here. Okay, q30 you can see from the table. V you can calculate using 4% interest rate. Similarly, this you can see from the table or whatever formula you know. This is probability. This is probability from the table you get. And using 4%, find V, V square, VQ. These are also given in the table, okay, at 4%. So you multiply all and you go up to Px. I mean, it will depend, okay, because total you have to go up to 120. If X is 30, I can write 120 minus X also, okay. And that way you calculate what if A is 30 or 40. That way you write all the terms. You calculate these and you add all these. Okay, you can verify for one, but it will take a lot of time. Okay, maybe one day for you, and you'll be able to match this one, but we don't need, because ultimately we need to solve problems. So we'll take term by term. This is whole life. Whole life means all the terms are present. Okay, if you take 1 year only, then what will happen? We'll take one term. Suppose in term insurance policy you want to take only one term, then that will be for 1 year term. If 2 terms you write, that will be for 2-year term. If 3 terms you will take, that will be 3-year term assurance policy. If you take 4 terms, that will be 4-year term assurance policy. If you take all the terms, that will be whole life policy. Let me write each one now. We'll use we have nothing here. So again, these are notations. You don't think that you don't know. If you know, there is a problem. If you don't know, that's fine. Okay, 1-year term assurance policy, 2-year term assurance policy, 3-year term assurance policy. We write this way. 4-year term assurance policy. Then 5-year term assurance policy. 6-year term assurance policy. It will continue this way. Okay. Also, we have to write a 1 here. Also, we have to write a 1 here, 1 here, 1 here. It gets complicated, right? But yeah, I mean, first time you will feel that way. But if you remember, these are symbols only. Why there is a 1? There is a reason. Let's not worry about that. So AX1, that is the first term here. QXB. Even if you don't understand anything, okay, then also if you know this page, you will be able to do everything. You will be able to solve all the problems. QXB, that is the first term I have to write here. This is whole life. Remember, this is whole life policy. This is 1-year term assurance policy. 1-year term assurance policy. This is 2-year term assurance policy. This is 3-year term assurance policy. This is 4-year term assurance policy. You write only one term. If you use general reasoning, this is valid for only 1 year. Now this is the second term. Okay, this is the second term. So we'll write here the second term. This is valid for 2 years. And we'll write 3 terms here. We'll write 4 terms here. Okay. Px1 qx plus 1 v square, px2 qx plus 2 v power 3. And if it's 4 years, so you write 4 terms. That way you can continue. And here you have to write all terms. This is whole life. This is 1 year. See, I'll tell you. 1 year means this. The person is fit and fine, age X now. If this guy survives, if this guy dies here, then only benefit will be paid. With what probability? QX probability. Discount it, V. That's all. If the person dies here, no benefit. So we'll not include a second term. The second term will come if you have benefit for 2 years. Okay, 2 terms. 2 terms for 2-year benefits. 3 terms for 3-year benefits. 4 terms for 4-year benefits. For whole life, all the terms must be there. That way you need to remember. That's all. So there is a connection between this and all the individual ones. So let me write the notations for all types of policies now. Whole life, AX. Endowment, AXN. Okay. Then pure endowment, that will be AX1 here. Then term, AXN1 here. 4 is 3 plus 2. That means this one is AXN is this plus this. Remember, AXN is this plus this. There is a small 2 line derivation. We'll do that later. No more derivation today. Just remember AXN1. This is what you need to remember. This is whole life policy. This is a term policy. This is a pure endowment policy. This is endowment policy. Using general reasoning also, I'll write a bit. Then we'll do 1 or 2 problems. Now, suppose we have a 3-year policy, endowment policy. I'm saying about endowment policy, 3-year endowment policy. So when I say endowment policy, suppose this guy is X. This guy is fit and fine now. If he dies here, then there is a benefit here. If he dies here, then there is a benefit here. If this guy dies here, then there is a benefit here. If the guy survive also, if the guy survives till the end of the term, then also there is a benefit here. Okay. So benefit here, benefit here, benefit here. These are the death benefits and there is a survival benefit. Using general reasoning, let me write. Okay. So this will be AX3. That will be this benefit. Okay. 1. I'm talking about 1 unit of benefit. So this is X plus 1, X plus 2, X plus 3. You write QX. Benefit of 1, V. Okay, this one is over. Present value of this one, present value of this one. Present value of this one. Plus present value of this one as well, because this is not term, this is endowment. There is a survival benefit as well. So condition to survival, if the person survives all the 3 years, remember the transitive rule. He has to survive the first year, second year, third year, all the years. So you can write PX2, PX plus 2, or maybe PX3 directly. Why write P both the times? Surviving all the 3 years. Okay. So you write V3 here, V2, V3, right? Okay. So this one in respect of this one, in respect of this one, in respect of this one. So there is a problem here. I have to write V power 3. Okay. So these are the 4 terms. This one anyway AX3, and if I write for these 3, that will be AX31. This is the notation. This is our term assurance. Okay. This is our term assurance. This is our term assurance. And this one is endowment part. We'll derive this one later, don't worry. Okay. So this one will be AX31 here, this way. We'll derive all these, but I mean, little bit is required. Let me write 3-4 problems. We'll do here all problems. One problem let's do. Okay. Black or maybe green. Let me write one example. This is good. Example. Let me write 4 parts here. First one is whole life. And second one is endowment. And the third one is term. Fourth one is pure endowment. For all you have to do, okay? What you need to find? Find the single premium at the outset. Payable by the policyholder. This is the question. Find the single premium payable by the policyholder. In all these cases, okay? What else given? Present age given. Present age is 30, okay? And in case of term, it's a 20-year term. In case of whole life, it's for whole life, okay? I can write whole life. This is 20-year. Endowment also, I can write 20-year. Pure endowment also 20-year. What are the benefits? Benefit will be, suppose, 20,000 pounds. Payable. When payable? Payable at the end of year of death. We are discussing only this one. Okay. What else you need? You know the age, you know the benefit, when it is paid, that is the time of the payment, that also you know. So you know the age, you know the benefit, you know the time of payment. You might ask, what is the pure endowment benefit? If nothing is given, both are same. If he dies, 20,000. If he survives, also 20,000. So equation of value, you need to find this one. The premium in this case, you have to write the equation of value. Present age is 30. So A30 will come. P will be equal to 20,000 A30. That's all. It's so easy, right? It's so easy. Now suppose you have to write the equation of value and solve this one. You have to write 20,000 A30 20. That's all. So then how to see the table, find the values. Okay. A lot of things are there. We'll discuss in the next class. But I'm writing only the equation. Okay. A30 is available in the table. Whether this is available or not. If these are available, then like partially, some are available, some are not available. Okay. We'll discuss in the next class. P will be, in this case, 20,000 A30 21. Okay. And in this case, it will be 20,000 A30 21 here. And for this one also we'll derive. See, I've written here informally. Informally, I said this term, this is the only term responsible. Okay. He has to survive, then only there is a benefit. That one will come here. But we'll not worry about this. We know already this one. And we'll try to find all these in the next class. Mostly the derivation part is over. Whatever I taught today, that you need to remember. Those symbols you need to remember. And from the next class, you see, mostly I'm saying 80 to 90% of the cases, the problems will be like whatever you have done when you started CM1. That was a part of CT1, which is CT1. This is a part of CT5, which is part 2 of CM1. Okay. This much for today's class.